Welcome back, students. In the previous video, we learned that sound travels in the form of a longitudinal wave. Now, let's understand the two most important part of a longitudinal wave. First, compression, and second, rarefaction. First, imagine air particles at their normal positions. This is called the undisturbed medium. When a sound is produced, the particle moves to and fro at some place. Particle comes very close together. This region is called compression. In compression, the density is high and the pressure is also high. At other places, particle moves far apart. This region is called rarefaction. In rarefaction, the density is low and pressure is also low. As the sound wave moves, compression and rarefaction are formed one after another and travels through the medium. Now, let's compare both of them in detail. Now, let's compare compression and rarefaction side by side. In compression, particles are closest together. In rarefaction, particles are furthest apart. Compression is the region of high pressure and high density. Rarefaction is the region of low pressure and low density. During compression, particle moves towards each other. During rarefaction, particles move away from each other. One more important point. On the graph of a longitudinal wave, compression corresponds to the crest, while rarefaction corresponds to the throat. So remember this comparison carefully because it is very important for exams. Now let's see how compression and rarefaction appear on a graph. Longitudinal wave graph. Here we can see a longitudinal sound wave along with its graph. Notice that compression and rarefaction are produced one after another. Remember, the particles themselves do not travel with the wave. They only vibrate to and fro about their mean position, while the disturbance moves forward. Now, look at the graph below. The highest point, called the crest, represents compression where pressure and density are maximum. The lowest point, called the throat, represents rarefaction while pressure and density are minimum. So, whenever you see a graph of a sound wave, crest means compression and throat means rarefaction. Now, let's understand this concept with a simple activity. Activity 11.4. This is NCERT Activity 11.4. Takes a slinky and ask a friend to hold one end. Stretch the slinky and give it a quick push and pull. You will observe that compression and rarefaction are formed and move through the slinky. Now focus on the marked green dot. Does this dot move from one end to another? No, it's only oscillate to and fro around its main position. This proves an important fact. The disturbance travels, but the particles of the medium do not travel with the wave. So, we conclude that a longitudinal wave consists of compression and rarefaction, while the particles simply vibrate parallel to the direction of wave propagation. Now, let's learn something very important. Now, all waves need a medium to travel. Based on the need for a medium, waves are divided into two types. The first type is mechanical waves. Mechanical waves need a material medium like solid, liquid or gases to travel. Examples include sound waves, waves on a string, wave on a string and ripple on water. These waves cannot travel in vacuum or space. The second type is electromagnetic waves. These waves do not need any material medium. They can travel through vacuum, which is why sunlight reaches the earth from the sun. Examples include visible light, radio waves, X-rays, gamma rays, etc.